Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazid bin Muhammad Ahmad Zamani. My meeting number EA E10027. So I will present for the introduction part. The best known controller used in industrial control process are proportional integral derivative, which is PID controller, because of their simple structure and robust performance in a wide range of operating conditions. The PID idea is widely utilized in applications that require precise and optimal automatic control. The PID controller is distinguishes by its ability to apply accurate and optimal control by utilizing the three control terms of proportional, integral, and derivative influence on the controller output. The proportional gain, integral time constant, and derivative time constant must all be specified when designing such a controller. So far, considerable work has been expended in developing approaches to reduce the time spent optimizing the selection of the controller parameter. That's all from the introduction part. Okay, the objective of the project is to adjust the reaction of PID controller to set point change and unmeasured disturbance such that variability of control error is minimized. Second is to illustrate the importance of traditional and modern control system in modern technology for long-term development. The last one is to illustrate the opportunity to resolve a control system challenge by using relevant engineering method. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif bin Zahiruddin. So today I will explain about some of our literature review. So the most popular control algorithm in use in industry is the speed control system, which has gained widespread acceptance in industrial control. Controlling the speed of DC motor is one of the applications employed here. A DC motor speed needs to be carefully managed because even a little variation might cause the closed loop system to become unstable. So automatic tuning is used in the creation of the PID controller utilizing the DC motor mathematical model. The PID controller in MATLAB, Simulink, and a real motor are both to be used to test the PID parameter. So now we go to the first literature review. So the first one of the literature review that we get is investigation of time delay controller design strategies for an electromechanical system. So a collection of time delay controller strategies for an electromechanical system are presented in this study. The controller's design requirement and electrical tuning techniques are highlighted with a review relevant literature. Also discuss our controller application and perform evaluations. This paper presents a conscious review of delay control design methodologies. So in terms of a number of performance indicators, the controller performed satisfactorily. This control strategy is simple to put into practice for real-world scenarios. Additionally, we have shown a performance comparison between the proposed delay type of controller scheme and the PID, which is proportional integral derivative, similar controller. So for the next literature review is robust fine-tuned PID controller using Taguchi method for regulating DC motor speed. So any rotational electromechanical system can achieve a satisfying response with the best proportional integral derivative PID controller architecture. The Taguchi method is used in this ratio to offer an ideal PID controller designed for a DC motor. The search space for the optimization issue is made up of the proportional gain, the integral gain, and the derivative gain. The goal of PID optimization is to reduce the step response integral squared error. So for the Taguchi technique, employs analysis of the means to get the anticipated optimum values for the control variables. So the performance of the Taguchi method-based fine-tuned PID controller is superior to the conventional open-loop Ziegler-Nicholas methodology according to the computer simulation. So I think that's all for me. Thank you.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Hilmi Hazib bin Afami, matrix number AE190048. So for today, I would like to explain about our project problem elaboration. So as we know, our title project is PID controller for speed control system. So the goal of the project is to create a PID controller that can control the speed of the DC motor. As our title report, in this project, we will investigate the efficiency and performance of a DC motor with a control approach implementation. So, in order to achieve all these project objective, so we need to do these following steps in order to get the result. So the first one is do some research about PID controller and DC motor for control system, and then we will summarize the single project from the literature review, and then identify all the components needed for the system. After we identify all the components, we will derive and simulate the mathematical model and block diagram by using MATLAB. And then we will analyze the result and discuss in the report.
Good day everyone, my name is Shafiq bin Ghasmanzudi and my message number is AE100107, and now I will explain to you about the problem execution and results. So this here, this is the mathematical and block diagram derivation. So this is the system data that we get from equation. The first thing to do is we need to do the data transform of the system equation. Then we need to do the first equation, apply to motor, do the data transform of the mathematical equation from equation, substitute the equation 2 and 3 into the IA, and substitute the equation 4 and 5 to the equation 1. And then after that, we get the A, and from the A can get value for the function is 1.2x over 0.0295 s power of 3 plus 2.732 s power of 2 and plus 1.6392 s, and here is the manual tuning of PID gain. So this is the character equations. So by doing the cross multiply, we will get the answer, the value for the A and B, and from that we are going to find the K value. See the K value K critical, which is 118.652, and this is the value for the S 1.2. And then after we find the value, we can get the value for the KP for the P type, for the KP, TI and KI for the PI controller type, and for the KP, TI, KI, TD and KD for the PID controller type here. And next, I will explain to you about the result examinations. So this is the figure 1 is the subsystem of DC motor embedded simulating, and here is the manual, and this is the manual tuning PID controller response. Basically, this is the manual and automatic PID controller response. So this one for this block diagram is for the manual, while this one is for the automatic. So the scope one, the graph one is for the input speed, which is the 500 RPMs and 1500 RPM. This is the response. Input. This is the graph show the input and output response. Here is for input and output responsiveness for 900 RPM and 1500 RPM. Next is the graph for the P controller manual output response for 900 RPMs and 1500 RPMs. Here you can see the difference here. The height, this value is around 1800, meanwhile here is 2800. And here is the graph for the PI controller manual output response. The value of the input speed is 900 RPMs and 1500 RPMs. And then this graph for the PID controller manual output responsiveness. This one is for the 900 RPMs. This is the graph, and this is the specifications. And this one graph is for 1400 RPM. So this is the specification here. And this for the scope 5, this one is the PIG controller automatic output response signal. So the graph is become like this, and for 900 RPMs, this is the specifications. The subsystem is referred to the automatic PID automatic signal. Subsystem 4, the subsystem 4. This one is for the 1400 RPMs signal for automatic PID. And then we need to do the comparison between the PID controller automatic versus manual output response signal. So from the result that we get from the MATLAB here, so we finally found that the value for the KP, KI, and KD for manual and automatic PID tuning. And here is the result. This is the result of the comparison between the automatic and manual. So here is for 900 RPMs above here, and the below here is for 1500 RPMs. And this is specification in MATLAB Simulink. So from the specification here, we can put the value for the 0S, TP, TR, TS, and ESS for manual and automatic. So that's all for me.
Now I will explain about our conclusion of our project. So as for the conclusion, based on what we got from the previous result, it shows that we were able to explain and solve the control system engineering problem using control system theory, techniques, and concepts. In this project, we use MATLAB Simulink software as our medium to build and create the DC motor system and got an answer for our results. It is important to take note that it will be implement the design of our PID controller. We can also demonstrate the importance of classical and modern control system in current technology for sustainable development and get to add some knowledge of how PID design block diagrams have DC motors in them. The basic concept is that we know that a PID controller is proportional and integral control modes are essential for most control loops, while its derivative is useful only in some cases. So for our project, we think we can relate the result of software simulation and manual calculation.